Hi, grade 11s. So we're still busy with applications of radian measure. We are now moving on to area of a sector. So if we have a look here, a sector is like a pizza slice. Okay, so again, you will get the minor sector, and then here's the major sector. Okay, so again, it's just like a pizza slice. So your formula is A is equal to half r squared theta. This formula will be given on the formula sheet. Again, we can derive 2 from this. We can solve for r, so r will be equal to the square root of 2a over theta, and then over here, theta is equal to 2a over r squared. And just remember, obviously, a is for the area, r is the radius, and then theta is the angle between your two radii. And remember, that must be in radians. Okay, so I am working from this page over here, and it is page 88, so you can just follow from there in your books. All right, so let's go into the first example. So example 1, they're telling us that we have an arc PQ. So what I'm going to do is just draw up the picture. So we have an arc PQ of a circle center O and radius r centimeters, and it subtends an angle of theta radians at O. The area of the sector formed by the arc PQ is a centimeters squared. Calculate the unknown in each case. So question A, they've given us that r is equal to 4.5. Theta is equal to 0.65, and we are missing the A, the area. Okay, so from our formula, A is equal to half r squared theta. That's the one I'm going to be using. So A is equal to a half r squared theta. Just plug in your values, and we get a half 4.5 squared multiplied by 0.65. Put that on your calculator, and you will get an area of 6.581 centimeters squared. Okay, so what that's done, it's worked out this pizza slice there. Okay, question B, they've given us that A is equal to 15, theta is equal to 3 pi by 2, and we are missing the r. Okay, so the formula that I'm going to be using is this one over here to calculate what r is. So r is equal to 2a over theta and a square root. Substitute my values in, and we get 2 times 15 over 3 pi by 2 and a square root. Plug that in the calculator, and you will get a radius of 2.523 centimeters. Right, question C. Question C is saying that we have an area of 120. We have a radius of 8.5, and we are missing the angle. Okay, so the formula I'm going to be using for this one is theta is equal to 2a over r squared. Theta is equal to 2a over r squared. Substitute our values in. So 2 times 120 over 8.5 squared, and we get an angle of 3.322 radians. Okay, going on to example 2. Example 2 is saying a circle of diameter 6 centimeters has a minor arc of AB which subtends a central angle of 2 radians. So if I draw up this picture, we have a radius of 6 centimeters And then they go on to say we've got a minor arc AB. So if that's A and that's B, so the minor would be the smaller one, which subtends a central angle of 2 radians. Determine the area of the minor sector, so this one here, and then hence the area of the major sector. Okay, so first of all, what I need to do is I need to figure out what my radius is. So we know that R is going to be equal to a half of the diameter. So we get the radius is equal to 3 centimeters. Okay, so the next thing I'm going to do is work out the area of the minor sector. So we get that A is equal to a half R squared theta. And our radius we've just worked out to be 3. And our theta is 2. So we get there an area of, sorry, this is squared. We get an area of 9 centimeters squared. Okay, so what I've worked out there is the area of this little pizza slice over here. Okay, so the next part of the question is saying, and then determine the area of the major sector. So we need to now work out the area of this big part here. Now you guys know that the area for any circle is pi r squared. So what I'm going to do to work out the area of this major sector, I'm going to take the area of the full circle, subtract the area of the minor. So we'll get pi r squared minus 9. And that will be what we're left with is the major sector. So we get here pi 3 squared minus 9. Plug that onto the calculator and we get 19,274 centimeters squared. And this is the major sector. Okay, going on to example 3. Okay, so example 3 is saying determine the area of a sector of a circle with a central angle of 70 degrees and an arc length of 18 centimeters. So if I just call this AB, they told us that this is 70 degrees and we have an arc length of 18 centimeters and we want to work out this area here. Okay, so if I have a look at our formula, we know that A is equal to a half r squared theta. Now, we've got an angle, but it's in degrees. So what we need to do with that angle first is convert it into radians. So 70 degrees multiplied by pi over 180 will give us 7 pi by 18, and that's 9 radians. So we're now happy with that. The next thing that we need to do is we need to find the radius. Okay, now in order to find the radius, I know what my angle is, okay, and we also know what the arc length is. So if I say here that S is equal to r theta, we now know that that is 18 equals the r we don't know, but now we know what our angle is, 7 pi by 18, and we can work out what r is. So r would be 14,733 centimeters. Now that I have everything for this formula over here, I have my r, I have my theta, we can work out the area of that sector. So A is equal to half r squared theta, and we get a half 14,733 squared, and theta is 7 pi by 18. And you put that on the calculator, and we get 132,599 centimeters squared. And that is the area of that sector. Now, grade 11s, these next two examples here, I'm going to wait until we've done some other stuff first before I go on to these type of questions. You can even see here it says to be done later. So I want to do some stuff first with you guys before we get on to these two. But for homework, what you guys can do for me is you can do question 8, 9, 10, 11, and 12. This we'll come back to later once we've done stuff for this. All right, thanks, grade 11s.